Welcome back, aliens. My name is Navin Reddy, and let's continue with the series on Python. In the last video, we have worked on linear search, right? So we were having a list, and out of that list, we want to search for a particular element. So if the element is there, it will say found at, and it will also show the location, right, or the position of it. If the element is not there, it will simply print not found. So linear search is good, right? But then what if you have a list of, let's say, 1,000 values, and the value which you're searching for is on, let's say, after 800 values. So you're wasting so much of time. So as your list length increases, it will increase the time as well. So do we have a better way? And yes, we have one more search technique, which is a binary search. How that works? So before continuing with binary search, you have to understand in binary search, all the values have to be sorted, okay? So normally when you work with linear search, it's not compulsory to have the values sorted. We can have values in any order. But in case of binary search, you have to make sure that your values are sorted. That means if I provide initial values, example, we are putting values like this, right? So we will change it. We will have a value which is sorted, right? So let's say 4, 7, 8, 12, 45, 99. So let's say we have this value. So we have 6 values. I want to search for a particular value. So instead of going for a linear search here, we will going for binary search. Now how that works? So let's imagine we have a list here, right? And if you want to search for an element, what you will do is you will first specify the lower bound and the upper bound, okay? So as you can see, the first value is a lower bound here. So the first value itself is a lower bound, and the last value is the upper bound. You can say first or last, but then let's go with this word L or U. So L is the first index and U is the last index. Once you have assigned this thing, the next step you have to do is you have to find a mid index. Now how do you find a mid index? As name suggests, mid, it should be a midpoint of this lower and upper, right? So you will simply say lower plus upper divided by 2, you will get mid value. Now whenever you say mid value, so in this case you can see we got the mid value there, right? So the element, let's say, okay, so before going ahead, let me find element. Let's specify the element. I want to search 45. Okay, so if you want to search 45, so you can see we got the mid value, right? So what's the mid value? So the index value for 4 is 0, the index value for 99 is 5, so 0 plus 5 is 5, and 5 divided by 2 is 2, right? So we are doing integer division here, right? We are not doing float division, so we are doing int division. So it will give you 2. So the value at index value 2, so basically your mid is 2 now. So the value at that index is 8, right? So now we got 8 as the mid value. The next step is you have to check the mid value which you have got is matching with the element which you're searching for. The element we are searching for is 45, right? So it's not matching. Now the next step would be you have to change your lower bound or upper bound. For the next iteration, you have to change your lower bound or upper bound. Now which one to change? For this, you have to check the value you're searching for is smaller or bigger than the mid value. If the value is smaller, change your upper bound. That means you will simply say the mid value is the new upper bound. If your value is greater than the mid value, so the mid value here is 8, right? And the value which you're searching for is 45. So now you have to change your lower bound. So what you will do is, so the old lower bound now, it will shift to the mid value. So your M becomes L. Right? So instead of having a big list, now you got a small list, right? So the list starts with 8 and it ends at 99. Now you got a new lower and the upper value. So what you will do, you will again find a mid value. So that's what you have to do every time. So your lower plus upper. So what is your lower? Lower is basically 2 and your upper is 5. So 2 plus 5 is 7. 7 divided by 2 is 3, right? So now 12 becomes your new mid value. Is it matching? Again, the same thing, it's not matching, right? We are searching for 45. Now you have to change your lower value again because 45 is bigger than 12. So you will shift your lower value to 12 now. So your 12 is the lower value and 99 is the upper value. So what you will do now is you will simply say mid again. The lower value is 3, the upper value is 5, so mid becomes 4, and at 4 we have 45, right? So now you will check. And you got the value. Now you might be thinking, oh, is it a good way of doing that? And the answer is yes, because in the initial level, you are skipping some values. You're not checking all the values. If your list is big, it will skip a lot of values which you're not checking, okay? So it will improve the speed as well. The only thing is the values which you are taking should be sorted. Let's implement this with the code now. So what we are going to do is, let's keep the same code. We have the list of values here. Let's search for 45. And so we are saying search, list, we are passing the list, we are passing n, but we have to change something, right? We have to change the logic here. So let me just remove the entire stuff. This is something which will change, right? Now the first thing is you have to mention the lower bound, upper bound, right? So you will say L is equal to 0. So you will always start L with 0. And you will say U, which is the upper bound. So L is lower bound, U is upper bound. Upper bound will be the length of the array, right? So you will say length of the least minus 1, because it should be 1 less than this stuff. Now once you got the lower and upper, let's apply a loop. This time again I will go with a while loop. Now till what point you have to reach there? So you have to stop at two scenarios. One, the moment you found the value, and second, your lower bound should not be greater than upper bound. Okay, if that happens, you have to stop it. So your lower bound should be always less than or equal to the upper bound. Okay, it should be less than or equal to. Okay, it should not be greater than or equal to. And then you have to also stop at the moment you find the value, right? So let's do that later. So in this while, you have to find the mid value now, right? So once we got lower, once we got upper, every time you have to find the mid value. So you will take mid is equal to, how do you find mid? It's lower plus upper by 2, right? So you will say lower plus upper, and you have to say divided by 2. So you will keep this in bracket. Now you want an integer division, right? You don't want a normal division. So you will use double slash, which we have done before. Double slash will give you integer division, and you got mid value. Now you will check if the mid value, so mid index. So we have to find the value for the mid index, right? And the way you do that is by saying list of mid. If this is matching with the value which you're searching for, which is n, our job is done, right? You will simply print found. In fact, I also want to mention the position, right? So you will say pos is equal to mid, because that's the position you were looking for. Oh, but pos becomes a local variable, right? So let's make it global variable here. We are saving that position as well. And then we have to do one more thing. We simply have to say break, right? That's very important. Or we can simply say return true. Why I'm using semicolon everywhere? That's it. Once you got the value, you will simply return true. Otherwise, what if the value is not there? So you will go for else. If the value is not matching, in else you have to do some extra stuff, which is you have to say if. Now we have to change your lower bound, upper bound, right? Because if you remember, if your mid value is not matching with the value which you're searching for, you have to change your lower bound or the upper bound. Which one to change? Depend upon the value is greater than the mid value or smaller than the mid value. So you will check list of mid is smaller. If it is smaller than the mid value, you have to change your upper bound, right? So you will say if that is smaller than the value which you're searching for, which is n, change the lower bound, and in the other case you have to change the upper bound. Now let's see if that works. I feel something is wrong, but let's verify. So what I will do is I will simply run this code. It works. You can see that it says found at 5. Is it right? 4, 7, 8, 12 and 5, 45. That's great, right? And let me just do it for some other value now. Let's say maybe 7. And you can see if you're searching for 7, it will still work. You can see it says 2. And if you have a bigger list as well, let me just add some more values to here. So it doesn't matter how big value you're searching for. And let me search for 10987. Now, if the moment you search for this, or on this, you can see it says at 9 position. Is it right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's great. So this is how you do a binary search. So just to repeat, just to reiterate, what we are doing here is, so we got the lower bound, we got the upper bound, and then you are finding the mid value. So mid value is basically the addition of lower bound, upper bound divided by 2. Okay. Now once you got the mid value, you have to compare that mid value with the value which you're searching for. If it is matching, that's great. So if it is not matching, in that scenario, you will again find a new mid value. But before finding a new min value, you have to change your lower bound or the upper bound. So because you have to reduce the size of the array or the list, right? So depend upon it belongs to right hand side or left hand side, you will change it. So that's how it works. But then we have not done for something which is not there. Example, if I search for 10, and you can see we don't have 10. It should print not found, right? It is not printing anything. So at the end here, you have to return false, because ultimately you're working with true and false. And don't use semicolon, because I work on the languages which use semicolon there. Let's ignore that. Oh, it's still not working. It still not says not found. Is it we have to do +1? So for the lower bound, you have to shift to the mid +1. For the upper bound, because see, if mid is not available, then why you have to even check for mid now, right? Mid is done. So you have to say L is equal to mid +1, but for upper bound, you have to say -1, because you have to skip that mid value, right? I guess that's the issue. Let's run this code. Oh, you can see it says not found. That's great. So we got the output. This is how you do binary search, okay? So watch this video once again and do practice. That's how you will improve your skills. So I hope you are enjoying this series. Let me know in the comment section and do subscribe for further videos.